Yet another conversion of a Harbor Freight 90 amp AC welder to DC. I think my conversion makes about the 12th, something around there, double digit. So it's going to have the electrode's going to be negative, and the grounding clamp's going to be positive. The one thing that's got to go is the fan. That's it's a really bad fan, and secondly, it's blowing air on the transformer. This is the replacement fan that I got for my build that I'm going to make, and it's an AC muffin fan. It's like 100 AC volts to or volts AC to like 110 or 120, and it comes with the AC cord, which of course I cut off, and I'm just going to heat shrink it onto, solder and heat shrink it onto the cord for the old fan that was on here. So in my opinion, the big mistake that everybody makes is they have the air, and even the way this was built is they have the air blowing onto the transformer, which it's like you're trying to make a positive air pressure, a higher air pressure inside the cabinet than that's outside. And what you're going to do is form air pockets that you're not going to be able to push out of the case, and it's going to just cause more heat inside the case. What you need is to create a negative air pressure to more negative than the outside air pressure. So every little crack and every vent was going to be drawing air in across the components, which I guess, spoiler alert, it really does cool the welder down. I welded for half an hour, 45 minutes without having to overheat it or turn it off. And I think that works really good. So, I mean, every piece of equipment I've ever seen, electronics equipment, it's always pulling air through the equipment over top of everything and pushing it out the back. In fact, a lot of computers are like that. And yeah, I mean, the only thing in a computer that you have air blown on it's the heat shrink, the heat sink for the processor. But outside of that, all your fans are trying to pull air through the computer and out the back. And all electronics equipment, from oscilloscopes and signal generators, they all work the same way. They always have the air drawn through the equipment. You can take your choice of what you're going to use to make a little divot so you can drill out the hole. I used a screw and also used a punch. I drilled my new holes for the cooling fan. I pop riveted the fan to the case. I cut the wires for the old fan. I trimmed the wires. I used butt connectors to connect the two wires together. I taped up the spool of gasless flux wire that's already on the welder, so I can take it off without it coming unwound. Here's the bracket I made for my 160 amp bridge rectifier. Drilling all the mounting holes for the bracket. Drilled the holes in the top of the case by the wire spool. There's the bridge mounted to the bracket, and it's a three-phase AC bridge. So you're going to be the transformer's two-phase. So all you have to do is connect one wire to the top and one wire to the bottom, and just leave the center wire unattached. And the other two screws are for your positive and your negative. And there it is, mounted to the case, and I bolted it to the case for ease in case It seems like a lot of the people have troubles with. I think they used like a 100 amp bridge or something like that, but they shorted out their bridge. So that's one of the reasons why I got a 160 amp. I still bolted it on just in case. I removed all the screws out of the case screws, and I bent the back down a little bit on the welder to get access. The screws for the feet were in the way, and so I ground them down. There's my first capacitor mounted to the welder. Here are both of my polarized electrolytic capacitors. They both have a negative and positive terminal, and I have a bracket for them, and that is pop riveted to the bottom of the case. There's both of the capacitors and the bridge. There's the first cable I made. It's a positive cable for one of the electrolytic capacitors, and I put shrink tape on the connection. There's a cable from the positive terminal on the bridge rectifier to the positive terminal on the electrolytic capacitor, and then I'll run another cable from the positive of that capacitor to the positive of the other capacitor. And that's a grounding cable. I think it's from one capacitor to the other, from the negative of one capacitor to the other capacitor. And there's a negative cable from the one capacitor to the negative terminal on the bridge rectifier. And that is a negative cable from one capacitor to the other. And there's the, I think that's probably the grounding clamp that I've cut the wire in half. And then the grounding, the wire that goes to actually goes to the grounding clamp, the right part that's been cut, that will actually go back to the positive terminal on the bridge rectifier. Then the other end will go to the AC terminal, one of the AC terminals on the bridge rectifier. There's the first wire that's going to go to the positive terminal on the bridge rectifier, and I used a butt connector, or put both wires in there, and it's got like a hole in the middle of the connector. And I have a soldering iron. I can't even guess how many watts it is. I know it's over 75 watts because I have one that I know is 75 watts back from the old, tube day, way before digital. And, he had tube TVs and stuff. Well, I'll go into that another time. But anyway, so I just took some electronic solder and I just heated that connector up and just kept, there's a lot of solder in there. And then when it cooled down, I crimped both ends, and then I slid a piece of shrink tubing over the other end and shrinked it down with a heat gun. Then I use some, I don't know what you call them, wire loops or wire stays or something like that. And I put the wires through that and pop riveted, drilled the holes and then pop riveted those to the case to hold the wire steady. So I started obsessing about cutting the wire that goes to the electrode or the gun, and the wire goes up and it goes through the unit that feeds the flux wire out. And both the flux wire, I guess it's in a channel, and then also the wire that goes to the electrode are in one giant jacket that goes down to the gun or the electrode. And where I'm cutting the wire, there's a circuit board right underneath of it. And I was thinking, cut it, solder it, and heat shrink it, and it's right on the circuit board. And I was kind of worried about dropping anything conductive, like solder or something on the board. And I could just remove the board then, but one thing I noticed that the potentiometer for the wire feed speed, it goes to it's sort of a PC type soldered potentiometer on the circuit board, and I don't think just taking the knob off I'll be able to remove it. So it's cardboard over the circuit board to protect it. There's the wire that I cut that goes up to the electrode or the gun, and so that's going to go back to the negative tap on the bridge, because remember we're going to have negative electrode and positive ground. These connectors are for 8 gauge. That's the gauge of wire I'm using. It's basically the same gauge everybody else that's doing these modifications is using. And the wire actually on the welders, it's like 9 gauge, it's just slightly a little bit bigger. These are the 8 gauge eyelets. And that's the soldering gun I was talking about. This was made to use for making stained glass. So I'm thinking it's like probably about 120, 130 watts, something like that. This one I just um, the first part, the part that goes to the gun, it's at the bottom. That I filled through the hole. I filled solder, and then the other top part, I stuck the wire in there and just started pouring melting solder in there. I know you're supposed to, I tried tinning the wires and putting them in there, but once you tin them, they won't fit in there again. And I slid a piece of heat shrink over it. I'm shrinking the shrink wrap with a heat gun. And I drilled the holes and pop rivet the wire stays on the. I think that's the top. Yeah, the top of the welder. This is a picture of the bridge with everything connected to it, and it's except for one, and that's the bypass resistor. This is a bypass resistor, and basically what it does is if you didn't have this, The capacitors, they charge up. They have a decay rate, but if yes, it's a long time for an electrolytic capacitor, and if you touch the tip of that, maybe even up to an hour later, you could get a severe shock from it. So the resistor bleeds that off after you turn off the power. But I noticed it up to as much as like a couple minutes. If I touch the tip to something that's grounded, it will spark still. But at least it bleeds it off within minutes. And I covered the ends of the resistor with liquid tape. It's a liquid electrical tape. And I haven't seen this for years. A company called CG used to make it back in the electronics, the analog electronics days. And I haven't seen it since then. I got this at Harbor Freight Tools. It's really good. I was going to put it on the tops of the capacitors and screw tops, and I decided not to. I just put it on the resistors. So this is really weird. This is something else I changed. This is the way the grill is on the sides of the welder, and they're the way they are. Like if you spill something down the side of the fan, I mean down the side of the welder, they're gonna act like funnels, and whatever you spill down there, it's gonna run right into the welder. So I took them off and I put them around the other way. They don't look like I think they made them backwards. I think that's what they did. But if you reverse them around, and one side will stick out a little bit to protect the controls on the front, so you have to make sure you get those right. Especially if you're going to put something on it, make sure you got them right the right way. There's the old grounding clamp. Well, that's now going to be, it's not really grounding, and now it's going to be positive. I also bought a better grounding clamp. And there's the new grounding clamp. So another mod that everybody's making, I did too, is I took the nozzle off the end of the welder, and the nozzle's for like if you're using a shielding gas. And so since you're not using a shielding gas, there's really no need for the nozzle. The only thing is to protect the threads in case I ever want to put it back on. I put some a piece of shrink tubing over it, and I shrunk it down over the end. And the removable part at the very end you can take off, and it's you have to change it for the different size wire. Well, that's charged, and I noticed while I was working, I touched the work with it, and it sort of kind of like makes a strange noise on the welder, like it's grounding it out. I don't know if it's good for it or not. And so I'm going to put a piece of shrink tubing over that part too. I put a dab of hot glue from a hot glue gun on the fan, so the connector won't come on disconnected. So that's it, and I'm really pleased with the way the welder turns out. It's not perfect, but it's definitely 100% better than it was. And one of the mistakes that I made when I first used it after the mod was that I didn't have enough wire coming out. So you got to make sure if you're welding something substantial, you got to have some wire coming out. I had it on like 2 and 3, and it welded fairly well. I'm very well pleased with the way it turned out.